So in this emitter, the first mode we want to show you is the pulse CW, and to show you that you're going to still see 2 channels on the digital oscilloscope of the 4 channels of RF that's being created. But I'm also going to force in the software. This is the open air range application we have where we can force an emitter to a certain RF channel so we can cable up to high power amplifiers and directional antennas. In the lab, sometimes you don't want to do that. But in the lab like this, to force it to a spectrum analyzer, we can use the same feature. So channel 1 assigned to the spectrum analyzer and also channel 1 on the digital oscilloscope is going to be the pulse CW when we hit run. So what we have here, channel 1 in blue is just the pulse CW. At the center frequency, it looks pretty static because there's only 1 pulse width, 1 PRI, and 1 center frequency, no offset, no modulation. Pretty simple, and what that looks like on the spectrum analyzer. What that looks like on the spectrum analyzer is a very simple sine x over x or sync function. Centered around it, you could see very clearly a very fixed pulse width PRI in the frequency domain based on the main lobe and side lobe width. So that's a very simple pulse CW, and we'll move on to the next modulation in a second.